Okay, guys. So you guys, some of you have already done this exam, and I want to kind of just give you a preface on what this is supposed to be. First of all, this is a community college Compass placement practice exam. So if you don't know what that is an exam that you typically will take going into college, and they'll see what your placement is. So if you had pre-cal your senior year, you'd go in, you would take this, you would see what class do you need to do. Your goal, at the end of your senior year is that you should be at pre-cal or AB calculus, maybe BC calculus, an AP class like might be AP stats, could be linear algebra. You know, the point behind taking a class your senior year is not necessarily. I mean, you do want to challenge yourself, but you want to take a higher level class so that when you get to this point, you can ace this test. And what this does is this not only it could save you thousands of dollars because either A, if you test poorly on it, they'll make you take a prerequisite class, which doesn't count towards your degree. So first of all, if you do well, then you don't do that one, and then B, you could test out of this, and you don't have to take any classes. For example, when I did elementary education classes, I actually took this test and I tested out of them. But luckily for me, I kind of at the time wasn't really thinking logically of money because I was young and dumb. But I'm glad I did. I ended up taking them anyways because it ended up helping me in teaching wise. So let's just go through this real quick. I want to go really quickly on this. If you have a specific question, please let me know. So around 793,749,621 to the nearest 100,000. So 100,000 is right here, and we look back, and it's a 4, so we round down. So now 793 stays the same. So that doesn't work, so we're only looking at these two, and the idea is that it stays the same, so it's got to be C. Find the sum. And just FYI, what you really want to try to do is you want to do as much of this without a calculator as you possibly can. Some tests, I do know when I had a couple students take it at U of L, the first portion of the test is non-calculator, and if you don't pass it, then you don't move on to the calculator portion. Subtract 3752 from 9030. So to make sure you're subtracting 3752. So we borrow. That makes this 8. Now, what I would do is 8. First number is 8. That one doesn't work. So I have 2 minus 5. Again, that doesn't work. So we got can't borrow anything from 0. So we're going to make this 8. Then we're going to make this 9. And we got 12. So we got 12 minus 5, which gives me 7. So do I have any that is 7, 8 at the end? Oh, it's right here. If I'm pressed for time. That is a testing 101. Okay, now multiply 557 by 605. Now, I hope that they don't give you a calculator for this. Then it's a smaller number. But let's just say they give you a calculator for this one, and we're going to type it into our handy dandy calculator. And let's see, 557 times 605. That gives us 336,985. Again, we're this one. We're going to see. Hopefully, it's divided by 49. It gives me 1,166. Find the quotient. Now, and if you see here, we have a couple that might have a remainder. So we're going to try this. We're going to do 31,252 divided by 37. So this gives us is 844.6. We'll say 65. Now 840. So it has a remainder. So that doesn't work. So it's either got to be 20 or 24. Let me give you a trick. What you do is you take 0.65 and you're going to multiply that by 37. and that gives you 24.05. We rounded, so it would be C. Right, so that's at 0.65 times 37, because this tells me how much I have remain. I don't know why I put 4.6. 5. Come on, 5. All right, now simplify. So in my mind, we should be able to do this in our head. So PEMDAS, right? Parentheses, exponents. We have an exponent right here, which is 25. So 2. Now we do multiplication. So 2 times 4, which is 8, plus. Don't do anything with that plus. And we have 4 times 25. 4 times 25 is 100. We have 8 plus 100 gives me 108. Same thing here. So we're going to do exponent first. So this is going to be 65 minus, so this is 2 times 2 times 2, which gives me 8, times. Now, remember, it's parentheses. So 12 minus 7, that gives me 5. Okay, so now we do multiplication. 8 times 5, which is 40. 65 minus 40 gives me 25, and that's it. I know I'm going quick with this, guys, but just go with me on it. All right, now here's another thing. So there's a couple ways of doing this. In my mind, what I would like to do is I would like to cut this in 2 different places. And why did I do this? Because I know that this rectangle is a 29 by 7. This rectangle is 23 by 7. And so it gives us the area. Again, I need to get my calculator out. Let's see here. 29 times 7 plus 23 times 7. It gives me 364. Now notice none of that's down here, but that's because every square foot or square meter is $3. We have to multiply that by 3. That gives me 1,092. Oops. Now, just an interesting tidbit. If you type this in like this, I believe it gets you 657 or something like that. So you got to know you're doing this first. You'd find the area first, and then you're going to multiply it by how much it costs. All right, next one. What is our fraction here? So we have 8. So we do parts over whole. So we have 8 of the whole, and it's shaded in 3 parts. So we have 3 over 8. Express as a mixed number. Now, if you don't know how to do this, what you do is you divide. So how many times does 3 go into 32? Well, it goes in 10 times. All right. So let me set this up. 32. So we have 1. 3 goes into 2 0 times with a remainder of 2. But that 2 is still being divided by 3. So it's 10 2/3. And this is a key idea to know for dividing by polynomials. The remainder is still 2, and you're dividing it by 3. Right, in simplest form. If you have a calculator, you can stick it in and you can find it. But what do we know? 625 divided by 1,000. What goes into both? So I think 625 divided by 25 gives me 25. 1,000 divided by 25 gives me 40. I chose that because I know 625 is divisible by 25 because it ends at 25, and I know 1,000 is. But this isn't done, right? These can both still be divided by 5, which gives, so if I divide by 5, divide by 5, it gives me 5 over 8. Gives me D. All right, lowest common denominator. So what does both 35 and 20 go into to make this work? Okay, now, I'm going to show you how to do this. 35 and 20. Make sure I did that right. 35 and 20. Okay. One of the ways is that you just start listing 35. So 35 times 2 is 70. Plus 35 is 105. Plus 35 is 140. 40, 60, 80, 100, 120, 140. Oh, there we go. We got one that matches. So 140 works. Also, if you could factor it out into a prime factorization tree. 35 is divisible by 7 times 5. Those are both primes. We're done. 20 is 5 and 4. 5 is a prime, so we can't do that, but we have 4 right here at 2 and 2. First, what I do is I circle what's in common. They both have a 5 when I write it down here. Nothing else is in common, so then I write times 7 times 2 times 2, and lo and behold, that would get me 140. I know this is quick, guys, but just trying to make sure I get through everything. All right. Oh no, this is an interesting one. Add and simplify. Okay, well first off, what do I see? I see 4, 16, 18. Oh, and they all go into 16. But to get from 4 to 16, I have to multiply this by 4. So multiply this by 4. This one's 16 already. This one I multiply by 2. When I rewrite it, it becomes 4 over 16 plus 7 over 16 plus 8 over 16. I want to add these together, which gives me, let's see here, 19 over 16. Make sure I did all that right. Let's see here. 2. Yep, okay. 19 over 16. Well, 16 only goes into 19 once. And then with that, we only have 3 left over. And lo and behold, it is B. Oh, this was C. All right, so this one. So when we're adding these, we can just add these 5s. That gives us 10. And then we're dealing with 6 and 8. Well, what does 6 and 8 both go into? Oh, they both go into 24. To go from 6 to 24, you have to do 4. Multiply that by 4. So I multiply top by 4, which gives me 20. To go from 8 to 24, I have to multiply it by 3, which gives me 7 gives me 21, right? So this is by 3, 3, 4, 4. And again, you can do prime factorization tree. You could also list. When it comes to smallish numbers, this is a fairly quick way of doing it. But when you start getting really large and complex numbers, the factorization tree is really the way to go. All right. So we're going to add these. This gives me 41 over 24. So how many 24s go into 41? Just 1. But we already have a 10 out here, so we have 11. If I do, once I take 24 out of here, what am I left with? Well, I'm left with 17 over 24. So really, once I got to this, and I was confident with it, I probably could have stopped because I was the only one that had an 11. Okay, we're going to do this one. Now, subtraction sometimes isn't too bad. It really kind of boils down to our fractions when we do them, and if the first one's larger than the second one. So 7 and 3, they're both prime, so it has to be 21. So I multiply 7 by 3 to get to 21. So I multiply this 6, which gives me 18, and 3 by 7, so I have to multiply the 1 by 7, which gives me 7. So this one's being okay. 18 minus 7 gives me 11 over 21. And then I'll just subtract the 3 and the 13 and the 3, which gives me 10. Now multiplication is a little bit more difficult in the sense of you do have to make them into an improper fraction. So 3 times 1 is 3, add 2 gives me 5 over 3. 5 times 4 is 20. 20 plus 4 is 24. Now, the nice thing about this is that when I do multiplication, I can cancel things out. So like these fives can cancel out to be 1s. 3 goes into 24 8 times, so it is 8. All right. Now divide. We have to do the same thing, but we're going to do keep, change, flip. So we're going to do first, we're going to do 8 times 5, which is 40. Add 5 gives me 45. Now keep, change, flip means I keep this number, I change this to multiplication. But instead of this being 9 over 1, we make it 1 over 9. And again, it's very nice. 9 can go into 45. So it just leaves me with 5 over 8, which is D. All right. So write the answer as a mixed number as needed. The recipe calls for 1 1/3 cups. How much water would be needed for half the recipe? So we would say, now, what's interesting, if I do, let's make this into a mixed fraction. It's 4/3. I could divide that by 2. Does that make sense? I want it in half. So I need to divide it by 2. Or keep, change, flip. It gives me 2/3. Tia pays her babysitter $8 per hour, so 2.5 hours, 2 3/4 hour. We need to figure out how much does she get. So let's add. So we can add our whole numbers, which is 4. But then we got to add 1/2 and 3/4. So that becomes 2 over 4 because our lowest common denominator is 4. So this is going to give me, so 2 plus 3 is 5. Okay, well, how many 4s go into 5? 1. So we add that to this 4 out here. So it gives us 5 and 1/4. And then we need to multiply this by $8. So if we did, now this is kind of interesting. If I do 21 over 4 times 8. 4 can go into 8 twice. So 21 times 2, which is 42. All right, round to the nearest 10,000. So this is 10, 100, 1,000, 10,000. So sorry, near 1,000. So we're going to round to here. So we're looking at 6. So it should be 87126. 87126. All right, the rest of these I'm going to do with a calculator just to make sure that I don't make this too long of a video. 86.3 plus 23.246, enter. I get 206, so I get D. And then 72.5 times 3.4, 246.5. 0.4 squared gives me a 0.16. 47.57 divided by 7.1 gives me 6.7. Express as a decimal. So again, all I'm going to do is going to do 5 divided by 8, which gives me 0.625. So let's see here. So n minus 7. So let's see here. We want the quotient of n and 7. Okay, so 7 less than n. Well, that's not too bad. I kind of like that. Quotient is not subtraction, right? So n less than 7. That usually means this. 7 decreased by n. Those kind of mean the same thing. So 7 less than n. So let's say it would be x is equal to, how do I find something that's 7 less? So if you own 7 fewer dollars than I did, you could subtract from 7, so that'd be A. All right, and that's it. That was really, really quick. If you guys have any questions over that, please, please, please don't hesitate to reach out.